What's up, Math 8? This is Mr. Bainey, and this lesson is 4.4, Proportional and Non-Proportional Situations. The standard up on the top right is 8.f.2, and the essential question is, how can you distinguish between proportional and non-proportional situations? So this lesson is the last lesson of the module and attempts to pull in all the things that you've learned for Module 3 and Module 4, everything that we know about what it means to be proportional and non-proportional. And we're going to be looking at different types of representations here. So there is an example in the middle of a graph on whether or not it is proportional or not. We're going to look at the your terms here on the bottom. So we first want to be able to identify, is it linear or not? So you have to first ask, is it linear? So I'm going to put a sort of some notes up here at the top. So we're going to ask, is it linear or is it nonlinear? And the only way it can be proportional is if it's linear. So if linear, is it proportional? And what that means is if it's nonlinear, we're not asking this question. It's already going to be non-proportional. So we're not interested if it's nonlinear, or I shouldn't say it that way, but if it's nonlinear, it's automatically going to be non-proportional. So number one and number two you see here are both linear. Linear means straight line. From there, if it is linear, it can be either proportional or non-proportional. And the easiest way is just to tell that where does it intersect on this y-axis. So this thing right here, this y-axis on number one and y-axis on number two, where is it intersecting the that line? And this one is 0, 1, it looks like. And so we're going to say this is, this is actually, number one is non-proportional because it doesn't go through 0, 0, it goes through 0, 1 as the y-intercept. So if you can at least find a different y-intercept other than 0, 0 for that line, it's non-proportional. Number two is proportional because, as you can see on the graph, it has 0, 0 as the y-intercept. Okay, so be able to explain, the directions don't say it here, but be able to at least explain or justify why you think it's proportional or not from a graph. Okay, the next type of representation we're going to look at is an equation. This one's a little bit trickier because we're dealing with some variables here. So we know that our equations look like y equals mx plus b. And if it's proportional, then we have y equals kx, if you recall that from module 3. So you can start to think about what the difference is between y equals kx and y equals mx plus b. And it also tells you that if with the y equals mx plus b, it's proportional if b equals 0, and it's non-proportional if b is not 0. Okay, so we'll likely just use y equals mx plus b to compare. We'll look at the your terms at the bottom. Okay, number 5, I'm going to put y equals mx plus b because we're going to compare it to this d equals 65t. So the y kind of looks like lines up with the d, the x is with the t. And by the way, x and y are going to be variables when you compare to other equations. Variables like d and t in this case, or like, and if you see the other problems, it's going to be the p right here, or the s, it's going to be the n or the p here, it's going to be the d. So that's what x and y are supposed to be lined up with. Okay, m, our slope, is 65, and you can see here that I don't have a b. So here, b equals 0. And if you remember from the top of this page, when b is 0, what does that mean? It means that this is proportional. And remember, b is the y-intercept, so that means the y-intercept is 0. If you remember from the previous page on the graph, when it's 0, 0, that means it's proportional. It goes through that origin. Okay, number 6. I'm going to put y equals mx plus b right above this. Try to line everything up. So y is p, x is s. Then my slope is 0.1, and I do have a b this time. It's positive 2,000. Because I have b equals 2,000, this is non-proportional. Number 7, we're going to do the same thing. This one is really tricky this time because our y is n, but the x, this x is actually the p right here. And that means that the m is our -3 and b equals 450. Okay. Again, the only way I knew that was because the -3p had the variable, and the x and the y are the variables, or lined up with the variables. So this means it is non-proportional because we have a b. And finally, number 8. Number 8's a pretty advanced one because some of the things are moved around that it makes it very difficult for us here. So I'm gonna first start with the x, that lines up with the d there, and then the y, we don't have a y in this case, and that means that our m is the 12, and this b is going to be sort of represented by this 36. And because of that, this is going to be non-proportional. Don't worry about seeing something like number 8, especially for this module this year. You may be expected to know that in the future, but you know, try to be able to do problems like number 5 and number 6 for the most part. Okay, and our third type of representation here for relationships is through a table. So we're going to look at the your turns at the bottom, number 9, number 10, and we want to determine if this is represented by a proportional or non-proportional relationship. And the easiest way to tell from here is by taking y over x. And so if you remember, if it is proportional means that we have y equals kx, and that k is our constant of proportionality where we have y divided by x. So when we use the table, we got 3 different pairs of x and y. If we take y divided by x and always get the same thing, then it is proportional because we have a k. So from the first point, we got 30 divided by 2, which is 15. The second part here, we have 90 divided by 8, which gives us not 15. It looks like 11 point something. And then we don't really have to do the last one here, but it is not, looks like it's not going to give us 15. It's going to give us something like 10 point something. So because this is all different, we call this, the ratios are not constant, then it is non-proportional. And number 10, we do the same thing. So I'm going to take y divided by x. So 1 divided by 5, and that's actually, I can leave it like that as a fraction. It is going to be 0.2 once I actually divide it out and get a decimal. And the same thing with 8 over 40. I could reduce it. It reduces to 1/5. It's actually the same thing. Or in your calculator, you get 0.2. And then in 13 divided by 65, same thing, it reduces to 1/5 or converts to a decimal of 0.2. Because all of these give me the same thing, it is a proportional relationship. Okay, and we're done with this one. The last type of representation for relationships is a situation or a description, or what you might consider to be word problems. So the last your turn, number 11 here, we're just going to take a look at two different relationships, and we'll have to be able to compare and contrast them. So we have Test Prep Center A. The cost is represented by this equation right here. And C is the cost in dollars, H is the number of hours you attend. So this means that the cost is equal to $20 times the number of hours. So this means if it's 1 hour, 20 times 1 is 20 bucks. So for 1 hour, the cost is $20. For 2 hours, I'm actually going to put it right here. So if H is 1 hour, the cost is 20 bucks. If it's 2 hours, it's going to be 40 bucks. If it's 3 hours, it's going to be 60 bucks. 4 hours, it's going to be 80 bucks. So this is actually a proportional relationship. Proportional because it kind of looks like y equals kx. There's no y-intercept in this case. Or there is, but it's 0. Test Prep Center B charges $25 per hour, but you have a $100 coupon to reduce the cost. So reduce means that we're going to subtract those $100. So if I look at this one, the hours, if it's 1 hour, we're really doing $25 minus 100 because that's for the coupon. For 2 hours, it would be $50 minus 100. So technically, for hours 1 and 2, you're not paying anything. And even for hour 3, you're also not paying anything. And then hour 4, you're breaking even, still not paying anything. Okay, that coupon's helping out a lot in this case. And then when you get to hour 5, it's going to be $125 because $25 per hour for 5 hours. And then subtract 100, you'd actually pay $25 in this case. Okay. So this one is definitely a non-proportional relationship because we're not starting at 0. Non-proportional. So when you compare and contrast these situations, you can say that something like center A represents a proportional relationship. I'm going to abbreviate here because it starts at 0. It starts at $0, right, for the cost. Whereas center B actually starts at negative $100, negative because you have that coupon already with you. Test Prep Center B charges a higher rate, $25 per hour. Okay, Center A only charges $20 per hour. It is cheaper, but you don't have the coupon for Center A. All right, so be able to at least communicate or explain those differences and how it relates to the math and working out some of the cost for each of the places. Okay, and that's going to be it for this lesson. Thank you so much for watching. Hope it was helpful. Have a great day.